Hey all, welcome back to our adventures in trying to solve Advent of Code problems. When I opened up this puzzle, at first I thought it would be too difficult for me because I've seen something like this in a previous year, or long story short, I've been doing Advent of Code for about 3 months now. But in a previous year's puzzle, they had this chemistry theme, and that one at the moment was a bit difficult for me. However, now that I've read this over, I think I could solve at least part one, so let's see how this goes. Day 14, Extended Polymerization. The incredible pressures at this depth are starting to put a strain on your submarine. The submarine has polymerization equipment that would produce suitable materials to reinforce the submarine, and the nearby volcanically active cave should have the necessary input elements in sufficient quantities. By elements, they're just saying these capital letters. The submarine manual contains instructions for finding the optimal polymer formula. Specifically, it offers a polymer technique and a list of your pair insertion rules, which will be our puzzle input. You just need to work out what polymer would result after repeating the pair insertion process a few times. So, for example, we start with a molecular chain NNCB. Because we start with the pair NN, we're going to insert the letter C in between them. Next, whenever we see the pair NC, we're going to insert the letter B between them. And we keep going through these. So we'd finish off by saying whenever we see the pair CB, we're going to insert an H between them. So that's what's happening here. The polymer grows quickly. We're going to try to once again replicate the example, so hopefully we get these numbers that the puzzle maker has provided for us. And we'll go from there. Finally, at the end of part one, what do you get if you take the quantity of the most common element and subtract the quantity of the least common element? So let's see, we're on day 14. And what I want to put in my input files are these chains, or these so-called rules. And we'll do that again for this. Okay. And let me go ahead and open up RStudio. I'm going to bring up the tidyverse package pretty early because I do really like the string R package that comes with it. So this time around, in addition to those rules, those lines that had the arrows in it, you also are given a starting vector. And we'll once again bring in the example to work on first. Now, what we learned back in day 6, specifically the puzzle I really had trouble with, is that if we have a vector like this that's going to keep on expanding, at some point the computer is going to have difficulty handling it. So the smarter thing to do is keep forgetting I could just type outside the code blocks. Perhaps we can try to simply what I was going to say is keep track of how many times the letters A, B, C, etc. appear. But the issue is that we also have to keep track of the order of the letters. So that's not going to work. So instead, we need we're going to loop through this list here. So we have 1, 2, 3, 4. Well, I could have figured it out on this end. We have 16 instructions, and we're going to do these insertions on our first polymer. So let's see, how do I want to do this? We're going to string split puzzle input for this rule. We're going to split it at the arrow. And let's just go for 1 for now. So now that our rule split, oops, make sure I'm careful with the arrow. Our rule splits up the CH and the B. So old chain, I want the CH here, is the first element of the rule split. New chain, I want new chain to appear in the bottom left. I want new chain to be CBH. inserting the letter B between the C and the H. So I'm going to take I need to split up the C and the H first. And I got old chain split, the first letter. The second letter comes from after the arrow. And then the final letter comes from what's right before the arrow. Now we do our string replacement. And we're going to replace wherever we find the old chain with the new chain. So now, at the moment, our polymer is NNCB, and when we run this through, our polymer did not get affected because I only ran through one of the rules. Let me see if I could do that again. So we're starting out with our polymer NNCB running through this list of rules once. Now our polymer looks like that. And I actually got something that's longer than intended. So I haven't quite understood this puzzle yet. At the moment, I kind of wish I did this in Python because a Python dictionary would be excellent here. So what they're doing is between the N and the first two N's, so replacing the letter C, between the N and C, inserting the letter B, and between the C and B, they're inserting the letter H. So there's only 3 insertions, whereas I actually did way too many of them. So I have to adjust this a bit. So instead, why don't I just go ahead and make that data frame then? So instead, why don't we just create the data frame? We want whole chain to be n units long, and we want new chain to also be n units long. So now our data frame looks like this. Whenever we see the NN, we're gonna, that's not good. We're gonna insert a letter C. I gotta fix that. Let me double check things here. So if this rule is 1, string split, the first puzzle is CH and B, right? So that's that. Rule split 1 should be the CH. And what I forgot to do is update this. There we go. So now, whenever we see the NN, we insert a C according to the rules. Whenever we see an NC, we insert a capital B according to the rules. And whenever we see a CB, we insert an H. Fantastic. So now, I want to do the insertions. We're going to just do 1 for now. I want to know the length of our polymer. Lowercase n should be four at the moment. And because we're going in looking at pairs, we actually want to stop 1 before. And how do I want to do this? I think I want a new polymer. And its length is going to be n plus n minus 1. So the new polymer will have 7 spaces in it. This old chain will be our polymer at location I through I plus 1. And we've got to look up where the new chain will be in our data frame. So if we know that if we encounter letters NN, we're going to want to plug in NCN. And then new polymer. The first location, I believe, will be an odd number. Like that. And let's try this all out. So what happened here? Let's say I is 1. Our polymer looks like that. And I think when I indexed everything, I forgot to split up the polymer. Okay. So what do I want here? I want to string split our polymer and grab the individual letters, grab two of them, paste them back together, like so. So that way, when I equals 1, then this will grab the first 2 letters. When I is 2, this will grab the next 2 letters. And when I is 3, this will grab the last 2 letters. So now our polymer look like that. The new polymer so here, I probably want to string split yet again. And then finally, take the new polymer, which you can see in the lower left is separate letters. Now the thing is, I don't actually need to keep splitting and collapsing the letters, because what I'm going to need to do eventually is figure out which letters are the most common. So let's see how I could do this. What if instead I split the first polymer up that way? I could go back to just saying our polymer here dang it. But then the data frame search would be tougher. Okay. So this now constitutes one so-called step in the process. So now our polymer looks like that. I'm trying to get this string right here. So this grabs the this should grab the letters N, N. So this old chain is NN. This inserts the letter C. And now the new polymer looks like that. We kick this up to I is 2. From the old polymer, we should now grab the letters N, C. We would then be told to insert the letter B. And we have that there. Run that one more time. We should be grabbing the letters from the original polymer CB. We should be now being told to insert the letter H. We're looking at the last 3 elements. And that's fine. Huh. Because I'm not getting this sequence when I run the whole code. What am I doing wrong? Oh, I'm doing the update inside the for loop. That's what I'm doing wrong. Duh. Okay. So we start with that first polymer. We now have this updated polymer. There it is. Okay. So now we need to insert this into a bigger loop. So after one step, we're going to print some I just want to debug here and double check that I am getting the correct numbers. So after one step, we have a polymer length 7. After 2 steps, we should have a polymer length 13. What? I'm not updating the lengths of the new polymer. That's what's happening. Making some newbie mistakes. After 3 steps, we have length 25. After 5 steps, we have length 97. After 10 steps, we have length 3073. Okay. So now we need to do the table. We're going to do one more string split. And we're going to there are only 4 letters in here? I mean, I guess. B occurs 1749 times, C occurs 298 times, H occurs 191 times, and N occurs 865 times. There's a typo here. So then table slash values, I believe I could extract the numbers. And I believe we go as numeric, and we want to take the max of that minus the minimum of that. Okay. So we have now replicated the example in about 38 minutes. And I'm going to run this now on my main puzzle input. Let me time this as well for our curiosity. Took about 9 seconds. And we got the right answer. Yes. So we're looking at letter combinations like that. Or letter frequencies, I should say. Counts. Alright folks, let's see what part 2 has in store for us. The resulting polymer isn't nearly strong enough to reinforce the submarine. You'll need to run more steps of the pair insertion process, a total of 40 steps. I don't know if my computer can handle this. So let's run it on the example first, just to see if we get fair answer. We're increasing this to 40. If I really make videos professionally one day, I'd probably insert some music here to pass the time. So it looks like even for the example, this code would take a really long time. I'm gonna probably, for the sake of our sanity, stop the video and try to clean up the code and then post the answer as soon as I can. Alright, so we'll see how this finishes off, and then maybe I'll join you tomorrow for day 15 of Advent Code.